Hello everyone, so in this video, let us talk about the problem from LeetCode. The problem name is range sum query 2D in an immutable grid. So let us talk about the problem statement first. It states that you're given a 2D matrix named as matrix, which is used to handle multiple queries or different types. Now, what is the different queries that you have to handle for this particular matrix that is given to you like this? You have to calculate the sum of all the elements in the matrix inside the rectangle defined by the upper left corner, row 1, column 1, and lower right corner. So you are given some matrix with some certain values, and the values can be from negative to positive anywhere from 10 to the power 4, 10 to the power 4, minus 10 to the power 4 to 10 to the power 4 plus. Now you are given multiple queries for this particular matrix, and the query is also pretty much large, as you can see here. The number of queries 10 to the power 4. Okay. Now what you actually have to see is that for all these queries, you have to find out the sum of all the elements in a rectangle that is made by these two coordinates, that is row 1, column 1, row 2, column 2. So these are defining the top left and the bottom right points of rectangle. You have to find out the sum of all the elements inside that particular rectangle. That's it. Now, if you want to do it in a very brute force way, that for a particular rectangle, find out all the sum of all the elements, then that will take a lot of time because you have to iterate over all the elements inside the rectangle, and the number of queries is also pretty much large. So you have to somehow pre-compute certain values to find out the answer. Now let us take this example only and understand how we can pre-compute. This problem is somewhat similar to a problem of range query sum. If you want to find out the sum of a range, so you pre-compute the prefix sum. Now in this whole scenario as well, because it's a 2D matrix, you have to not only find out the prefix sum, but somewhat similar to that. You have to find out for that. So let's take an example. Let's bring out our board. What you can see here is that what eventually in our board is that we have taken this example. Now, what we'll eventually have to find out is, let's take some example that I want to find out the sum of all the elements inside this matrix. Okay, now what we can do here, what you can see here is that we can first find out the sum of all the elements in such a way that the top left is always the top element. Okay, because in the prefix sum, if you somewhat remember a prefix sum problem, what we eventually do is that we find out the sum of all the elements from the very start. We are also trying to do here the same. What we are trying to do is that we will make another matrix of the same size. Okay, we'll make one more matrix of the same size, an empty matrix. And what we'll do is that we will find out the sum of all the rectangles which has the top left corner here and the top right corner ending at every point possible. So let's say this is one rectangle, this is one rectangle, this is one rectangle, this is one rectangle. Okay, then other rectangles is this rectangle, this rectangle, this rectangle. Now the rectangles are these rectangles, this rectangle, this rectangle. So the overall idea is that all the rectangles that we're choosing has the top left here and the top right ending at every point. Okay, now you have to find out that. Now how can you find out that? That you can do using some sort of a memoization, that we have already computed some particular rectangles. Let us use that. Let's use that technology here, or like a logic here. Let's say that I have already find out the answer, but let's actually remove this out first. If can I just somewhat make this smaller? Let's move it here. Let's move one more smaller rectangle here. 2, 3, 4, and 1, 2, 3, 4. Okay. So the first value, that is rectangle starting from here. Just make it a little bit larger. Starting from here, rectangle that is ending here, that is including this box, is only 3. Rectangle ending at here, that is this rectangle, includes the first and the second element. The first element sum is here, and the second element sum is the sum of this element plus this element. So it will be 3 plus this element value, that is 3 eventually. The next value will be 4, next will be 8, 10. So the first row can be just directly calculated out with the element here with the element before it. Similarly here itself, the first column, the first element, the second element is the first element plus the element here, this element here. So this element is actually which you can find out here itself, because that's the value. If I want to find out the sum of the rectangle like this, it is the sum of all the elements. I know the sum of all the elements till this point. Like till this point, I know the sum of all the elements because I've already pre-calculated. Finding out this sum, this block, I will take this sum plus whatever element is here, that is 4. That is eventually equal to, let's say, 13, minus 14, and so on. Now you have the sum of all the elements in the first row and the first column. Now, how can we find out for all the rest ones? Okay, let's find out for this one. This one. The sum is like this. This is like a smaller one. Let's take a larger one for more example. Let's say I want to find out the sum of this rectangle using the previous values which we have calculated. So if I want to calculate the sum of this rectangle, I've already calculated the value for this, and this. Okay, this all these values are. Let's assume that we have already pre-calculated because we are moving in this direction. So we have already calculated all these values. Now we have to calculate this value. Now this value is eventually equal to, what you can see here is that this value is this rectangle. Now this rectangle consists of, if you want to find out this rectangle, and this value stays saved here, this rectangle whose value is saved here, and this rectangle is now taken twice, in the blue one and in the green one. So I have to remove it, and this rectangle value is stored here. So the value which comes out for this rectangle is this value, which is from here, that is, let's say, this 0, plus the sum which is here, plus here, subtracting this value. Okay, that's the overall logic to find out the value of every block. Okay, so let's take some logic and the code part to make it first more clear, and then we'll see how we can use this to get our final answer. So what we have done is that we have created a matrix that is answer to 200 by 200 because the maximum length is 200. The maximum length of the matrix is 200. Now what we have done is that we have pre-computed the first row and the first column, which I've told you, using like the first value is the first value, and all the rest value of the first column in the first row is calculated by taking the previous value plus the current value. For all the other values, the answer of I is the ith value in the matrix, ith value matrix, plus, as you can see, the top value, that is, let's take some other color, that is this value subtracting this value. So this value, that is the previous row, the previous column, adding both and subtracting the diagonal one. That will help us to calculate out the value of the sum of the sum. And if you just print out this, if I just print out for loop what is stored inside this, which you can see here, this is the, you can say, prefix sum, prefix square matrix, which is finding out the sum of the square ending at every point. If you take it, the top left to the very top left. So as you can see, that is 3. The sum of this square is 3 again. Sum of this is 4. This is 8, and so on. Okay. So this is the answer that we have. Okay. Now, how can we use this to eventually find out our answer? Let's take that into consideration. What you can see here is that, let's say that we want to find out the sum of this matrix. The value that we have just used, the method that we have just used, will be the method that we'll be using here itself. To find out the sum of this matrix, we'll take the sum from here till here, that is the complete square, the complete rectangle, subtract out this rectangle, and because this rectangle is taken twice, subtract out this one more time. And that's it. That's the complete logic for this particular problem for every matrix. So let's move on to the code part now. And that can be done in O of 1 because we have already pre-computed these values once. So for finding out the ith value, what we have done is that we will take the complete row to column 1, that is our bottom right point, and delete out some of the values. Now deleting out the values based upon where the matrix is positioned. Let's take one more example. Let's say the matrix we want to find out is this. In this matrix, we will take this matrix as the base matrix, from which we'll subtract out the matrix that is on the top. But there is no matrix on the left hand side and no matrix that is common. So we will not remove that. What is the case in which we have nothing in the left side and nothing that is common? The only case is that if the matrix that we have to find out is on the first column. So that's the overall logic. That if the value that we have to delete out depends upon whether our column 1 and the row 1 is the first row or the first column. Because if it's the first row, there is nothing on top that we have to delete. That is nothing in common as well. So that's we have to find out. If it is not the first row, then we have to take and delete out all the, let's say, rectangle on the top. If there is nothing on the, if there is something on the left hand side, more on the left hand side on the columns, then take that, delete it as well. If there is something in common as well, delete it as well. So that is the overall idea for finding out how much you have to delete from the actual bigger rectangle that we have to take and then delete it out from there. This is just O of 1, and that is pre-computed, and this is whole pre-computed initially in O of n into m, the matrix dimensions. That's it. That's the complete logic on the code part for this particular problem. If you still have any doubts, you can mention it in the comment box for this particular video. I will see you in the next one. Till keep coding and bye.